Hello and welcome to Weekly Code, the weekly show where I struggle to make an algorithm so you can laugh at me. I mean, so you can get some educational attainment. Within this episode, I'm pulling an algorithm out of the closet because the algorithms I was working on this week I did not have time to finish. Although I do have algorithms on the burner, and I plan to have those finished by next week. This one out of the closet is a problem a friend gave me, kind of as a challenge. It was funny. They didn't really know how mathematics worked, so I kind of explained it to them. Essentially, we have this trick question. Now, I'll explain to you why it's a trick question in a second. And yes, I did turn it into a full algorithm, even with the trick in it. Let tau be a set of functions. Tau equals f of j, being an element of x, being of x, equals pi multiplied by x up to over 24, plus b of j multiplied by x plus 589 multiplied by square root of negative b of j over 20. N is an element of natural numbers. We'll get back to what b of j is. Let a be the set of roots with a positive imaginary part of every function of tau. A equals y being an element of complex numbers, 0 equaling f of j being of y, imaginary y being greater than or equal to 0. Of course, that's how roots work. F of y being an element of tau. It's just a basic explanation of what it just said. Find the sum of every element of A. Round both the real and imaginary part to the nearest integer. Notice how b of j here, which I did not mention for this very reason, equals negative 1 over n up 2. You would think because of this negative b of j, this could easily create imaginary numbers. You were wrong, however. B of j equaling negative 1 over n up 2. Because this is negative, that makes it positive. As such, this is a trick question, and the answer will always be 0. However, I still made a function for it, just to piss off all the haters. As we see here, I made a function. I'm going to run it just so we can see the plot I added. Here I called a Euler number. I don't know why I called a Euler number. This was supposed to be pi. I do not remember why I ever called a Euler number. I think I just thought it was a Euler number at first. Here's tau max. This is the maximum amount of calculations for tau. These would be the variables following tau max within a range 1 colon tau max. Here are just the necessary variables. Of course, I would love to see a plot, and you'll see a graph soon enough that compares these variables to the x values. Here we calculate tau. Now keep in mind, I do not like the way I coded this. I can code much better than this. I was flustered. I just kind of wanted to get this done. This was before I even started the series, so you know that this is one of those skeletons in the closet that I don't want to show people, but you all get it now. If tau max greater than 0 for I in these variables, iterator equals I up equals 2. Of course, here's what I was talking about. Tau divs 1 equals e, that should be pi, multiplied by I up 2. Tau divs 1 equals 24. I divided this into each individual function so we can then sum them appropriately. Tau divs 2 equals var multiplied by I. Tau divs 3 equals 589 multiplied by square root, complex, negative var. This is how you denote the ability to use complex numbers in Julia, by the complex function. Otherwise, this would not work. Or at least, it would not work if it wasn't a trick question. Tau divs 3 divide equal 20, and then you tell vowels using an iterator, and sum appropriately. Here's a sum where we simply sum the complex numbers. You used a type of to make sure the number you're comparing is complex. If it is complex, then of course we sum it in the root. I just realized I did not check for roots on this, which is kind of funny. But again, I just kind of wanted to get done with that. I just kind of threw this out there, and I probably should have added that. I knew I forgot something. And of course, here's the code for the plot. We have tau max and then tau vals. Well, the range to tau max and then tau vals. Yeah, and that should really do it for this week. Sorry for the short week. I have quite a few algorithms on the burner right now that I personally hope to finish very soon. Of course, I have social medias if you want to follow me. I have Twitter. I have my Discord channel. There's also donation links below. And of course, there's the GitHub you can watch. Thanks for watching.